Okay, 6.5, dividing by a monomial. So if we were to solve the equation 5x plus 3y equals 6 for y, meaning we want to isolate y, note this is a review of taking an equation from standard form into slope-intercept form. So this is standard form of a linear equation. How would we solve for y? Who can tell me? What would you do to get y by itself? Minus 5x from both sides? 3y equals negative 5x plus 6. How do you get y by itself now? Yeah, and it has to be, everything has to get divided by 3. So you would get y equals negative 5/3 x plus 2, correct? Summarize the last step involved in solving for y in the previous example. You said, I heard you say, divide everything, emphasis on the everything, by 3. Well, that's basically the same exact thing that we're doing in this example. We're taking a polynomial. How many terms does this polynomial have? Number of terms. What are the number of terms? 4 terms. What's the degree? Degree of 3, because it has the biggest exponent. Is it written in standard form? Yes, because it's in descending order, right? Degree of 3, degree of 2, degree of 1, degree of 0. It's written in standard form because it's in descending order. Now, basically, this is saying I'm going to divide everything by 4. And by the way, if you were going to put something like this in your calculator, I don't know why you would, because it's not going to do very much with the x's, but you would have to have an implied parentheses because all of those terms are being divided by 4. Now, just because 4 doesn't divide evenly into all of these terms doesn't mean you can't divide it by 4. You'll just get fractions. Oops. Negative 10x to the third divided by 4 plus 5x squared divided by 4 plus 8x divided by 4 minus 9 divided by 4. So we could also reduce any of these fractions, right? Everything is getting just divided by 4. And are there any fractions that you can see that can reduce? 8/4. So this one right here becomes what? 2x. That's nice. That's a whole number. An odd divided by an even, probably not so much, right? Plus 5x squared over 4. That's a positive. And then, can you reduce 10/4? 4 doesn't go evenly into 10, but it still could be reduced by half, right? They're both even, so that would be negative 5x to the third over 2. Because 10 over 4, if you divide each by 2, you would get 5 halves. I just didn't put the sign in there. Negative, there you go, negative. Okay, so that's all we're doing here with these problems is we're really just dividing. Now, if you're dividing by another variable, you're going to use those laws of exponents. So remember how we said that x to the 5th divided by x, what would that be? X to the 4th. We subtract the exponents. That's called the quotient law of exponents. Okay, so here 2x goes into 10x to the 5th. Well, 2 goes into 10 how many times? 5 times. X goes into x to the 5th, leaving x to the 4th. Does everybody see that law of exponent in action there? So we're actually dividing by an x. So every single exponent is going to be minus 1, right? What's 8 divided by 2? 4. And then x to the third divided by x is equal to x squared. Good. X squared. 4 divided by 2 is 2. X squared divided by x is x to the first. Yeah, just x. X to the first. Are we clear on that, how that works? All right, I'm going to have you guys do the rest of these problems and share out in just a moment, but they're pretty much, the same thing almost every time. I just want to point out something. People wanted me to go over another word problem. So shall we do the word problem at the end together? So this one says a cylinder's volume is a lot of polynomial here, 36 pi. Why does it involve pi, do you think? What's a cylinder? Yeah, it's round. It looks like a can of soda is a cylinder, right? And it has a radius. Okay, so they're telling us here that this is the volume, that V equals, okay, and that the base's area is given by this right here, square units. Find the height of the cylinder. So before, when I was talking about a little bit about geometry, I was saying that in order to find the volume here, the volume is the area of the base times the height. So the base times the height. That's big B would be the area of the base. So the height is not being squared, but the area will be in square units, and then when you multiply by another unit, it will become cubed, right? So this area down here of the circle, the circular base, times the height, is going to give you that cubic units. So all we're doing here is we're saying, well, if I divide by the area, if I divide the volume by the area of the base, what's going to be left? The height. Okay, that's how I'll get h. So I'm going to take the 36 pi x to the 6 plus 27 pi x to the third plus 24 pi x to the second, and I'm going to divide the whole thing by the area, 9 pi x squared. So that means I'm really dividing that into each term. The volume is a trinomial, okay? So you could rewrite this as, this is going to be the height. The height is going to be equal to 36 pi x to the 6 divided by 9 pi x to the squared, x to the squared. So the height is going to be, and then plus 27 pi x to the third divided by 9 pi x squared plus 24 pi x squared. All I did is just write each one with that denominator, x squared. Okay, and now we can, of course, simplify. How many times is 36 divided by 9? 4. 4. What about pi divided by pi? What's that? 1. What is x to the 6 divided by x squared? X to the 4th, because we subtract the exponent. That's the quotient rule. Plus, how many times does 9 go into 27? 3, right? How many times does pi go into pi? Again, 1. They cancel, right? How many times does x to the third divide by x squared? X to the first, right? And then what about here? 9 into 24. Can that reduce? 9 does not go evenly into 24, but what number goes into 9 and 24 evenly? 3. 3 goes into 24 8 times. 3 goes into 9 3 times. So we get 8 thirds as the reduced fraction. And then what about our x squareds and our pi's? They cancel, yeah, because anything divided by itself, x squared divided by x squared is 1. So that's a really funny looking 8, but I'll fix it. So that's our last term would be 8 thirds. Any questions on that?